I work at a company called ADTRAN. About 3 years back, we started using Scala as one of our main development languages, and made the decision back then, which at the time, probably still, was sort of an unorthodox decision to use Gradle as our primary build tool. One reason was we knew we had several different languages that we wanted to support, including Java, potentially Groovy, potentially some embedded languages like C, C++. And we saw Gradle as being more flexible in that area. And we're sort of turned off at the time by SBT's sometimes cryptic nature, maybe lacking documentation. I think a lot of that has gotten better over the years. But I still find, if nothing else, when the Gradle documentation fails me, which is only occasionally, I never fail to get my answer from the source code. When I've tried the same thing with SBT, I always find myself with a headache instead. So y'all are probably familiar with this, right? In Scala, major versions of the language when they release are source compatible, but they're not binary compatible. And so if you're publishing a library, then you have to indicate which version of Scala that library was compiled for. And the convention in the Scala community is to do that by suffixing the name of your artifact with the epic and major version of Scala that it was compiled for. Then in Gradle, when you're listing out your dependencies, you declare your Scala library dependency, and Gradle looks at that, or I guess technically the Gradle Scala plugin looks at that and figures out which version of the compiler it should use. And then you end up sprinkling all these _211s through your dependency lists. You can make it a little better by sort of factoring that out into a variable. So we have a lot of projects that look like this, just using string interpolation inside our dependencies. But it still has the problem, right? And if you're building a library yourself, then you'll want to put the suffix of the version on your artifact as well. If you're just building a standalone executable, it's not as big a deal. But it still leaves the problem of what if you want to compile for and distribute for multiple versions of Scala at the same time. At least that I could tell, there was no great way to do this today. In SBT, which is sort of the de facto standard Scala build tool, it's trivial. You just list out the versions of Scala you want to support, and then in your dependencies list, you can use this magic %% operator between the group and the artifact ID, and it knows to then suffix the proper Scala version onto the artifact ID for you. And then it'll also automatically add that suffix to your jar file artifact or whatever. But there was really no good way to do that in Gradle that I could find. So I wrote a plugin, and that's what we're talking about today. Here's a little bit about me. I won't spend much time on this. You can find me on Twitter. Is probably the best place if you want to get in touch with me. As I said, I've been at ADTRAN for about 10 years. Most of that time was in embedded. They do networking and telecom stuff, so writing embedded C++ for networking gear. Are those slides cropping? Why did that suddenly start happening? Okay, so let's look at how the plugin works. I'll say it's sort of inspired by the SBT way. So in your settings.gradle, you would declare the list of Scala versions you want to compile for. And then in your dependencies, you can use these two placeholders. One is %scala-version%, and it represents the fully qualified version number. And the other is this _%%, which just stands for the suffix, which would just include, in this case, for example, _2.12 or _2.11. And so then if I have a task, like a simple my task that's going to print some text and include this variable that the plugin conveniently puts in scope for you, and I run that task from the command line, you can see my task runs 2 times, and it prints my task for Scala 2.12 and my task for Scala 2.11. The astute reader will notice this sort of intermediate task called recurse with Scala version 2.11.8, and we'll talk about what's going on there. It's got some other features. Sorry, I don't know why this is cropping off the side there, but you can control which versions of Scala it's going to execute by default. So if you just want to compile for like the latest one while you're iterating in development, but your CI server wants to run all of them, that's easy to achieve. It'll add the suffix to your jar file. It'll make sure your POM file dependency section is correct, and it supports multi-project builds. I'm not going to go into detail about how to configure the plugin and everything. It's well documented on its own GitHub page. Here's a link to the README if you want to figure out how to install it and set it up. Instead, I want to take some time to talk about a couple of challenges that I faced while trying to make this work, and how I solved some of those, and talk about some of the things that were surprisingly easy and some of the things that were maybe surprisingly difficult. So the first thing that I had to figure out how to do was how to produce multiple artifacts using a different set of dependencies. And after coming out of the keynote, it sounds like there's some new feature called variants that may be a better way to do this. And so maybe by this time next year, this will be obsolete. But in the meantime, maybe this plugin can help some other people too. And there were two different ways that I could think of, and I'm by no means a Gradle expert. So I sort of have this nagging fear that somebody's going to be like, that's dumb. Why'd you do that? You should have done this other thing. And if so, please tell me. That would be great if I learned something. But the two that I looked at were trying to sort of dynamically add a configuration, or using recursive, what I call I've got it in quotes there, recursive builds, and you'll see why. I considered trying to add configurations, but my head quickly started to hurt with how to line the tasks up and how to tell it which ones I wanted to build, and how to do the dependency resolvers on each one. So I ended up going with what I've sort of termed recursive builds. So it's based around this thing called a task type called GradleBuild, which essentially invokes a whole new instance of a GradleBuild, as if you invoked it from the command line. So the way my plugin works is, so you're probably aware, a GradleBuild has two phases, at least, I guess, sort of the evaluation phase and the execution phase. Or maybe this is more properly called configuration. I'm not sure. I call it evaluation because when I want to do stuff after it, I use after evaluate. So going into the first evaluation, it's going to read that Scala versions property from your Gradle.properties file. And that's going to have, for example, 3 versions of Scala in it. The plugin will see that and will choose the first one to execute in the current execution of Gradle. So here, version A is going to run, and it's going to run build and test with Scala version set to whatever version A was. Then it's going to also dynamically create an additional Gradle build task for each additional version of Scala in that list, and set the Scala version explicitly as a property for that build. So then the plugin, when it sees that Scala version has already been set, knows that it doesn't need to recurse further, and just executes the build and test for that version in that Gradle build execution. And then there's one of those for each one. So I struggled with how to represent this well. Does that make sense? Okay. This is how you would create a Gradle build task. This is a snippet of code from the plugin implementation. So it's just got the type Gradle build. We want to make sure that it inherits all the build parameters from the parent build. So that's what this line does. Then we're going to add some additional properties, right? So we're going to explicitly set the Scala version, singular, to the first version in the list. I went ahead and set this recursed flag so I could tell that I had recursed quickly and avoid a whole slew of logic that I didn't need to run through. This came from an issue that somebody filed against the project pretty early on. So by the way, issues and pull requests are welcome. If you find a problem, please let me know. Through GitHub issues is probably the best way. You can specify some tasks that you don't want to run for every version. So by default, that list includes clean, right? You typically wouldn't, if you included clean on the command line, you would just want to run that once and not for every subsequent version. And then it sets the tasks that invocation of Gradle should run, which we just copy from the exact same tasks that the user listed on the command line. So these Gradle build tasks are useful if you need to invoke Gradle with different high-level inputs. So that includes a different build file or build directory, What I'm using it for is for different build parameters, or you can invoke with different tasks. I suspect they could probably also be abused, and they do come with some caveats, which we're going to get into a few of those because they led to some additional challenges. But it led to a pretty clean API or user experience for using this plugin. You just run your tasks on the command line and it executes them for every version. So I think it worked out okay. Okay, so the second challenge was, okay, well now how do I get it to resolve those placeholders in the dependencies list, right? So like that percent Scala version and the underscore percent. And that is super easy. You just configure a resolution strategy on a configuration. So I just, for all configurations, I set a resolution strategy, and it's got this function each dependency. And I just, that will pass a dependency resolve details instance to this function. And then this dependency resolve details allows you to inspect the dependency that they requested. So that would be the one with the percents in it. And then you can call use target to say, don't use, here's how you resolve that. So I can do the string substitution in there quite easily. One caveat was that I noticed that if I called use target on a project dependency, like a sub-project or cross-project dependency, it was causing some errors. So I ended up protecting that with just a if statement that said, don't call this if nothing changed, right? So if there weren't any percent substitute placeholders in there, then just skip calling use target and resolve it the usual way. I then learned that Gradle seems to write the POM file, dependency section of your POM file, using the requested dependencies and not the resolved dependencies. So after I did this, I noticed that my POM files had percents all in them, and any project that didn't use my plugin didn't know what to do with that. So I found some, the Nebula suite of plugins from Netflix that some of you guys might know about. They had a plugin that did something similar to this, right? They wanted to take the plus signs out of versions so that you got a fixed version in your POM file of your dependencies, even if Gradle was using a version range. And so I was able to adapt some of that code. I don't expect you to read all this. It's small text, but I wanted to throw this code snippet up here because the Netflix plugin supported the new, I think it's years old at this point, but the newer Maven plugin or Maven publishing plugin, and a lot of our projects were still on the older one, the Maven plugin. So this snippet of code will call a function, in this case resolve Maven POM dependencies, with a POM object. It's just an XML object for both versions of the plugin, if you're using Maven or Maven Publish. So this could just end up being a useful snippet if you had to do anything similar. I also wanted to point out this line. For the Maven Publish plugin, it seems to set the artifact ID based on the project name, which in this case wouldn't have the suffix on it. Previously, we would add the suffix to our project names just to get it onto the artifact. But the Maven Publish plugin uses the project name, and so I needed to add the Scala suffix here. For the Maven plugin, it used the artifact name, which I had already set elsewhere in the plugin. So a slight difference between those two plugins here. Manipulating the POM was sort of an interesting exercise. Again, fortunately, I was able to sort of steal a lot of inspiration from the Nebula plugin. But this is the basic process I'm going through. I'm just walking through each dependency in the POM file, looking it up in the resolved dependencies from Gradle. And if there's a match, then I substitute the placeholders. And if it's a project dependency, right, so if this is a dependency on another project in this build, and that project, that sub-project, also uses this plugin, then its name won't include the suffix, and I need to re-add the suffix onto it, so I have to do that. Oops. And then I just loop through all the dependencies in the POM file. So that code's sort of interesting read, but it was far too long to put on a slide. But you can find it on GitHub if you're that interested. Okay, and I wanted to mention just a couple of things too about testing that I ran into. This isn't a talk about how to test plugins, but there were a few things I wanted to touch on. The plugin has two sets of tests, two different kinds of tests that I've sort of broken into what I would call unit tests and integration tests. The real difference is what testing tool they're based on. The unit tests are based on the project builder, which comes from the Gradle test kit, and the integration tests are based on the Gradle runner, also from the test kit. The unit tests are sort of built around a project, right? This project object that we all know and love from writing Gradle files. So it creates the project object and the test harness, applies the plugin, and then inspects the project and makes sure that the plugin manipulated it the way I expected it to. And then the integration tests actually invoke Gradle and inspect the command line output and the task results. So it's two sort of very different ways to test. The Gradle runner, let's see, and then this is sort of another thing that I used was I probably could have built up these test projects programmatically in the test bench, but I found it easier to sort of write out a simple project scaffold in the source code and check it in. And so I've got a little simple project in my source code that's got a build.gradle that applies the plugin. This was useful. I configured a little fake repo that's just a flat file system repo. These are all 0-byte files that just happen to look like jar files would look, and it allows me to test the dependency resolution that does work. And it adds some dummy tasks so I can inspect their output when I use Gradle runner. Here's how you build those two different things. Pretty similar. Project builder, you can set the project directory here, so I set that to that top level simple project folder. Similarly with the Gradle runner, you set the project directory and the arguments you want to call it with, just like you would on a command line. And then this project object is just the project object you're used to from a Gradle file or developing plugins. This results object lets you inspect the build results and inspect the status of any given task and the overall build as well. Okay, the biggest challenge for testing that I ran into was trying to keep the plugin, the thing I'm trying to test, on the class path. So particularly with the Gradle runner, it runs in its own process, so it doesn't inherit the class path or the class loader. And there's some workarounds on the Gradle documentation for how to deal with this. Apparently, if you're using this Java Gradle plugin development plugin, it will do some of that injection for you. Otherwise, there's this procedure that they have documented. Neither of those was sufficient when I was using this recursive GradleBuild task, because as far as I can tell, it doesn't create its own process, but it also doesn't seem to inherit the class path of the class loader. So this was the sort of convoluted workaround that I came up with to keep my just compiled plugin on the class path. The outer build.gradle uses the method sort of suggested on the Gradle documentation to write the class path out to a file in the build directory, just a new line separated list of .class files. And then it also puts that file on the class path when it runs the test bench. Okay, the test bench then writes that back out to disk inside that simple project build so that its build.gradle can read that file and put it on the class path and then apply the plugin and find it successfully. I don't know. I feel like there's probably some improvements that can be made here, maybe in that GradleBuild task type. I don't know if any of y'all are Gradle folks. Take that as a suggestion. But once all that was done, I was able to build a library and publish it for multiple versions of Scala quite easily. We're using it for a number of projects internally at ADTRAN, and would love to see it be used by other folks, at least until some better method comes around or more official thing from maybe the Scala. Maybe it'll eventually be built into the Scala plugin. That would be excellent. All right. We're at 12:15, and I think lunch is being served. So I'm happy to answer questions, but I'm not going to hold everybody up for that. So I'll just be around if anybody has questions. Sound good? Thanks.